Now it's time to consider the work of Isaac Newton. Isaac Newton is a pivotal figure in the history of science. He starts by describing science in words, descriptively, but he ends with mathematical reasoning. He's not the first to do this, but he's the most central in the entire history of physics. In fact, in hindsight, some of his work is not rigorous by modern standards, but his ideas were always original. On Newton's monument in Westminster Abbey, Alexander Pope penned the famous lines, "Nature and nature's laws lay hid in night. God said, let Newton be, and all was light." He was a complex personality. He was brilliant, acerbic, cranky, reluctant to publish. He mastered many subjects, and he was deeply, if unconventionally, religious, as we'll see. In his early life, he was born in Woolsthorpe, Lincolnshire, into a farming family. And when I visited there, I was relieved to see there is an apple orchard in the backyard. The famous apple tree of the myth of the apple falling on his head, of course, is long gone, but it's possible that it existed when he was growing up. He didn't have a happy childhood. His father died before he was born. His mother remarried, and it seems like his stepfather was not a nice man, who left Newton with his grandmother to be raised. He went to a nearby boys' grammar school, which was not a very high-class school, and he undoubtedly was never challenged. His mother tried to make him a farmer after her second husband died, but he was absent-minded and diffident as a child. There are famous stories told about Newton during these times when, for example, he was sent by his mother with a horse to market to sell the horse, and on the way he got distracted on a bridge and the horse slipped the trace, and he kept on walking, not realizing that the horse had slipped away. So he had these famous stories told about him. He enrolled in Trinity College, Cambridge, as a subcisar, which is a valet, because he was lower class. But by 1664, he was smart enough that he'd been given a scholarship. He studied mathematics and René Descartes' mathematics. And then he graduated just as Cambridge closed due to the Great Plague. During this time, there was really nothing to distinguish him as a student. Meanwhile, things were going on, and England was a turbulent place. There was a bitter political struggle between Parliament, with the ability to raise taxes, and the monarchy. The monarchy engaged in disastrous military adventures under the reign of Charles I and fought Parliament for a decade. Eventually, Parliament impeaches Charles I and executes him in 1649. This leads to the unstable period where the Commonwealth is established and Oliver Cromwell is named as the Lord Protector. There's anarchy in this time and then anarchy after Cromwell's death. The army recalls Charles II but forms a parliamentary monarchy, and that, luckily, preserves Britain from the violent revolutions that are being experienced elsewhere in Europe around this time. Then there's the Restoration, where Charles II is restored to the monarchy. This time becomes more stable and liberal, and we see the flowering of what's called the coffeehouse culture, a more egalitarian venue for intellectual discussion and centers of commerce and freewheeling trade. Gresham College is founded in London in 1645 by a rich merchant who has a civic-minded duty to share science and ideas with the general public. And so we see the beginning of a different sort of intellectual, an outward-looking intellectual, civic-minded, willing to tell the public about the clever ideas of science and philosophy. These are also men of a practical commercial bent. They're opposed to the church rule, which had been omnipresent in universities up to this time, and they're concerned with dialogue, with debate, and with experimentation. This leads to the charter of the Royal Society of London in 1660 from Charles II. It's the United Kingdom's version of the American and National Academy of Scientists. Initially, it's primarily composed of non-scientists. The Royal Society is the first published journal in 1667 called their Philosophical Transactions. It's a public record of new ideas. And that's a major issue in the history of science because it means ideas are now communicated in a fixed form. There's peer review, ideas are vetted by other scientists and thinkers, and this is a major force in the emerging professionalization of science. But still, there's turbulence. This is the year of the plague and the Great Fire of London. In 1665, the last outbreak of the bubonic plague killed more than 100,000 people in London, about a quarter of the population, in little more than a year. Newton returned home to Lincolnshire from Cambridge for safety because he lived in a small town where he could isolate himself. The Great Fire in London destroyed many homes, including most of the fancy homes of the best people in London. Poor people suffered the most, of course. The wooden homes did not survive. And these years, when he was isolated, his intellect blossomed, and they're called his annus mirabilis, his miracle year, for three great discoveries that he had of the calculus, the nature of life, and universal gravitation. Calculus was just a tool for Newton to deal with time-varying quantities. He developed a rather cumbersome notation, but it was a major breakthrough in dealing with moving objects, the dynamics of moving objects which he would need for gravity. Now, Gottfried Wilhelm Leibniz independently developed the same calculus, and they had different ways of doing the mathematics. Despite a collaboration early, they engaged in a bitter dispute over the rest of Leibniz's and Newton's life that lasted decades and was unresolved at the time that Leibniz died. In a sense, Leibniz won because we use his notation today and not Newton's. The philosophical notion of an infinitesimal that comes from calculus were problematic for many, and Bishop Berkeley, a philosopher of science at the time, ridiculed both Newton and Leibniz for expounding mathematical nonsense, since division by zero is undefined. But the calculus was an important way of making progress in physics. It was based on limiting principles that did not get perfected for another 150 years. But the lack of these rigorous underpinnings that came much later didn't deter physicists from using it to solve problems. Newton made wonderful contributions during his miracle year to the idea of optics and light. He showed that color is an intrinsic property of light. In his famous experiment, sunlight admitted into his study was passed through a prism and turned into its constituent colors. He decided and showed that dispersion by one prism could be undone by a second inverted prism, and that showed that the light colors were not produced by the prism itself, but were intrinsic to the white light. He saw that the dispersion varied by color, and that the largest deviation in the prism was for blue light, the shortest waves. He realized that the perceived color of any object is due to the object's reflection, differing for different colors, and not always due to some intrinsic property of the object. In Newton's mind, light was a particle, called the corpuscular theory of light. He also introduced the idea of an ether, which was the invisible medium that light traveled through, in a vacuum of space, obviously, as well as on Earth. In 1669, Newton returned to Cambridge. His reputation had soared because of the work he did during the plague years. He was named a Lucasian Professor of Mathematics. He developed designs for a reflecting telescope, an interference fringe method for testing telescopes and improving them, and this earned him membership as a Fellow of the Royal Society that had only been formed less than a decade before. He still had a reputation as an absent-minded scientist. He was a notoriously bad teacher, and stories are told about him at Cambridge at the time, how he would turn up to teach reluctantly, sometimes not at all, and the students would be perplexed by his puzzling notations. He would keep his back to them and write on the whiteboard, never turning to face them, never taking questions, and eventually many of them would just leave because he wasn't a very good teacher and they weren't learning much in the classroom. He also had a habit of, on the paths around the colleges in Cambridge, tracing out geometric proofs or notations in the gravel along the paths. And other faculty and students at Cambridge learned to avoid the diagrams that Newton left in the gravel, since he might come back to them later. During this time, he's very reluctant to publish any of his results. He doesn't really like the back and forth and the to and fro of scientific dispute. He's pretty much a sociopath and prefers life as a hermit. He's also a perfectionist, but much of his work has not yet been perfected. Well, that's difficult for him. And that's the end of this topic.